Hello. So in this movie I'm going to talk about another way to read the file via memory mapping that file. So in the previous video I discussed how to read from a file using a more traditional approach with file open, read and close. But today I'm going to discuss how to access the contents of a file by memory mapping it. And for this, we'll need two additional SYSCALLs, one to get the file size and one to memory map the file. I also have here the open file that will be used, the SYSCALL. I've already covered this in the previous video, so just quickly, we have in RDI the file name. In RUX, I'm setting the value 2, which corresponds to the open SYSCALL. In RSI, I have the constant read-only, which is actually a 0. In RDX, 0 and performing the SYSCALL. And the file descriptor will be returned into RUX. Now, for today's video, we don't need file read. We use file close. Again, what's happening here, we have in RDI the file descriptor. In RUX, I have the value 3 and perform the SYSCALL. And again, after the SYSCALL in RUX, we'll have 0 for success or -1 for error. Okay, so now let's take a look at these new functions. First is file size. So for the file size, we need in RDI the file descriptor, and in RUX I will return the file size. However, there is no SYSCALL for getting the file size. Instead, I'm using the fstat SYSCALL. So this is SYSCALL 5. And we need in RSI to pass a pointer to a stat structure, which will be filled. And then I'm checking here to see if the SYSCALL was successful. If not, I'm just jumping here and RUX will be a negative number. And if the SYSCALL was successful, then I'm reading the file length from the stat structure. So let's take a look how this stat structure looks like. I have here a temporary location for a stat structure. So it have a number of fields here, and here we see the size. So this will be the file size. It also returns the number of blocks allocated for the file, but this is usually larger if we have blocks times block size. This is usually larger than the actual size of the file. So we'll be using this for the file size. And now if we compute the position, we have here quads which occupy each 8 bytes. So we have 1, 2, 3. These occupy 4 bytes. So these two actually take again 8 bytes, so 4 8 bytes so far. 5, 6, and here we have the size. So to access the size, we need statbuff plus 48, so 6 times 8. So that's what I'm doing here. Yeah, so I'm reading into RUX the size of the file, and this will be returned. Of course, other registers are saved and restored when exiting the function. So this is the file size. So now let's take a look at the other call for memory mapping a file for reading. So what I'm doing here, I need the file name into RDI, and it will output the address where the file will be mapped, and also the size of this of the memory space allocated to the address in RUX. And this will correspond to the file size. So first we start by opening the file. We're using file open. Again, I'm checking to see if there was an error. If there was an error, I am jumping here. I considered setting rux to 0 and checking if we return 0, but then I decided against it. So in rux we'll actually have the error, which is a negative number. So again, we can check for a negative value when exiting this function. Okay, so we basically just exit, restoring first the registers. Okay, so now if we succeeded into opening the file without an error, then we need to get the file size. So we move the file descriptor into RDI. We also store it in R8 for later use, and I'm calling file size. And again, checking to see if we have an error. If not, then I'm first saving the file descriptor and the file length on the stack. I'm setting in RDI null, the null address. So in this case, the kernel will allocate memory. In RSI, I'm setting the requested size, which corresponds to the entire file length. So hopefully this will this can be fit in memory, but I'm working with small files, so there is no issue here. In RDX, I'm setting this requested protection level, so read, so we'll have read access to the memory. In R10, this memory mapping will be private to this process. In R8, we already have the file descriptor, so that's why I saved it here. Then I'm setting R9 to 0. This corresponds to an offset in the file, so we want to map from the start of the file. In rux, I'm setting 9, which corresponds to the memory mapping SYSCALL, and I'm calling SYSCALL. Now, after exiting the SYSCALL into RDX, I'm popping the file size, and this will be used when returning from the function, because I said in RDX we'll have the size. I'm also restoring the file descriptor in RDI, because I also want to close the file. So according to the documentation, after memory mapping a file, the file itself can be safely closed. And if we want to discontinue the mapping, we have the unmap SYSCALL, but I have not implemented unmap here. So after performing this, I'm checking if there was a mapping error. If so, again, exiting. Otherwise, I'm closing the file, and at this point, I have not checked for an error. So if we reached this place here, it means that the file was successfully opened, we successfully got its file size, we successfully mapped it, but for some reason we got a file close error. So is this an actual error from the mapping perspective? I don't know. So if you want, you can perform an additional check here using test, but otherwise I don't really care for an error here. So that's why I saved initially the value in rux, which was the address. I've restored it here, and so it will safely exit the routine. So now let's take a look at a very simple test file. So this one is even simpler than the previous one, using read. So what it does, it calls file map read. In RDI, it will receive the file name. It will display the contents of EAX and the contents of EDX. So this should be the address or an error code, and in EDX we should have the file length. I'm also testing for a possible error, and if so, I will display a message. Otherwise, I will display the contents of the file, which is in the memory mapped region. And the address was returned into RUX. So I'm setting this into RSI. In RDX, I already have the size, so I can call this console write. And I made a video about writing to the Linux console. I will leave a link in the description. So what's happening here? If there was an error, I'm just displaying the message. For display EAX, you saw this in the previous video, but what's happening, I'm converting the number to a string, and then I'm displaying the string first in decimal and then in hexadecimal. For displaying the EDX, I'm moving from RDX to RAX, calling again display EAX, so this function above, and finally restoring RUX. And I have here the message error mapping file, and I also have here the file name test read. File buffer is 4K, but this is not used. This is from the previous program, and I have here a buffer for the integer display. So now let's take a look. As usually, I have a build script that assembles and links everything. So let's run the test program. As you can see, there is no testread.txt file. So let's see what happens. So this is what happened. The map procedure returned this negative number here into RUX. In EDX, we have 0 and we have error mapping file. So now let's create testread.txt. So it was created. It has obviously size 0. And let's execute again the test. And again, we have an error here. Why? Because the size is 0. So now let's try to enter something here. This is a test file. So this has 20 bytes. So let's execute it again, and yeah, it worked. So we have a memory address that was returned here. We have the file size in RDX, which is 20. And we were able to display the contents of this file here. So I hope you enjoyed this video. If you did, don't forget to like and subscribe, and see you next time. Bye.